Okay, so now objective 2. Now, how do we find a value corresponding to a given probability? So now what we're going to do is we're still going to start, we're still going to start by drawing our standard normal distribution, standard normal distribution, with a mean equal to 0 and a standard deviation equal to 1. And again, it's going to look like this. But now we're going to be given an area. So in this case, they give you the 0.90 area. So notice, no matter if I use the actual mean and again the standard deviation, or if I use the standard normal distribution, everything corresponds. The areas are the same shaded region, and where the z value is located between the first and second standard deviation is exactly where your x value is between the first and standard deviations, okay? But in this case, what you're going to do is once you have the picture, you're going to find the z-score that corresponds to the probability. Now, let's recall that when you use the stats applet, you have to have a left tail probability, meaning that your probability statement must be z is less than some value equals a number, right? So be aware of that sometimes you have to use the idea that the area under the curve is equal to 1 to get you that situation. Okay, but again, you have to have a left tail probability. And now once you find this z value, then you're going to unstandardize that z value. So in this formula, you will have z, you will have the mean, and you'll have the standard deviation. And your job will be to solve for your value x. Solve for the value x. So it will require a little bit of algebra skill, okay? Not too tough. All right, so let's take a look at a problem and see what we can do. All right, so it says, example 3, how tall are 3-year-old girls? According to the CDC, the heights of 3-year-old girls, 3-year-old females, are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4 centimeters. 75% of 3-year-old girls are taller than what height? Okay, so in this problem, we are told that it is normally distributed, so that's important. That means we can do what we've been doing. We were given our mean of 94.5 and our standard deviation of 4. And we want to find the height at which 75% of our girls are taller than. This is kind of a tough problem to interpret, but here's what we are saying. We're saying that we know that the probability that our value or our girls' heights are taller than some value, and that's going to be 0.75. So 75% of our girls are taller than this value because x is representing the height of a 3-year-old female. All right. So this can still be thought of as find the probability that z is greater than some value, and it's going to be 0.75. However, greater than means this is the right tail. I need the left tail. So think about it real fast, right? 75% is somewhere around here. So if this is my value of x, this would be about 75%, 0.75. That means my left tail is going to be how much? Well, it's just going to be 1 minus 0.75, which is 0.25. That is the probability that I must use. So this problem, in order to become left-tailed, must be this. So for the left tail, I must use this probability statement. Find the probability, or I know the probability that z is less than some value is going to be equal to 0.25. Okay, this is left tail. So I'm going to take a picture of that, and that's what I'm going to use in my probability stats applet. Okay, and then I'm just going to take a picture of the whole screen so I know what my my z or my mean and standard deviation are as well. Okay, so let's go to the stats applet now, and let's take a look at this problem. Probability. Normal distribution, begin. Now, I am not calculating the area. I know the area. I have to calculate my z value. I know that the mean is always 0 and the standard deviation is always 1 for the standard normal curve. Now, it says calculate the value for the left tail area in that space has to go to 0.25. There. So this picture needs to be included in your uh, edge-elastic response. This area is 0.25, which means that this area here is 0.75. And this z, which is equal to negative 0.674, is the value of z, where you have those less than it or smaller than it is 25% of the people, and those greater than it are 75% of the people. This z is going to correspond to the actual height that determines this breakdown. Now our job is to unstandardize this. Remember that our mean is 94.5 and our standard deviation is 4. So your z formula is z equals x minus mu divided by sigma. You're going to replace these three things with what they are, but you're going to leave x alone. So z is negative 0.674 equals x minus 94.5 divided by 4. So how do we solve it? Well, it's a two-step process. First thing is get rid of this denominator by multiplying both sides by it. So I'll just use the dinky calculator to do that. So 4 times negative 0.674, that's negative 2.696. That is x minus 94.5. And then to get x all by itself, I need to add 94.5. And when I add 94.5, I get 91.804. That is my x value. Since the mean has one decimal, let's have this have one decimal. This 0 leaves the 8 and 8. This would be 91. Sorry. Sorry about that. 91.8, and that would be in centimeters. That is the height, right? That is going to be the height that separates those who are 25% less than it and 75% greater than it. Okay. Now, I do want to mention something. Let me go back to the notes real fast. You are going to see percentile problems on your homework. This problem, even though it says 75, this would not have been the 75th percentile. This would have actually been a 25th percentile question. Because when you do percentiles, whenever it says find the percentile, your picture is automatically this. This percentile is the probability less than. You're looking for the z value less than that to equal that area. So again, that's where this would have been the z, and that is your 0.25. So remember, anytime they give you a percentile, that is already giving you the left tail area. There's no need to fix it like we did in this problem. So I hope that makes sense to you. Okay. Best of luck on this homework. Yeah, ask me a question if you have them.